Hello guys and girls, this is Way Cool with another word problem video. Here's the question. The sum of two numbers is 43 and the difference of the numbers is 15. What are the two numbers? In this case we have two unknowns and thus would result in two equations. Now how do you know that it's going to be two equations? Well, if you look at the problem, you realize that for the first section of the problem it says the sum of two numbers is 43. Now right there, if you picture it, it would be number 1 plus number 2 equal 43, and that's would represent the first equation. The second part of the problem says that the difference of the numbers is 15. That means when you subtract the numbers from each other, you should get 15. So to represent the unknowns, we'll use two variables, x to represent the first number and y to represent the second number. For the first equation, we'll use x plus y equal 43. Sum of two numbers equal 43. That's going to be the first equation. The second equation is going to be x minus y equal 15. According to the problem, the difference of two numbers is 15. Okay, to solve for one of the unknown, we need to rewrite one of the equation to be in terms of x or in terms of y. In this case, we're going to choose to rewrite equation 2 to be in terms of x. What we will do in this case is to add y to both sides of the equation. In so doing, we will be able to eliminate y from the left hand side of the equation. Thus equation 2 in terms of x would be x equal 15 plus y. From here, we can show that this is indeed equation 2, but it is rewritten in terms of x. Okay, what we will now do is to plug the new equation 2 into equation 1 by substituting the variable x. So we have the new equation as 15 plus y, which would be for the variable x, plus y equal 43. Our goal now is to get this new equation in terms of y. In order for us to accomplish this, we would have to group like terms together. The first thing we will do is to subtract 15 from both sides of the equation and then add the y variables together. This will allow us to eliminate the 15, which goes to 0. So now we have a new equation, which is 2y equal 43 subtract 15. By subtracting 15 from the 43, we can rewrite the new equation to be 2y equals 28. Remember, our goal is to get y by itself. 2y is not y. So we have to get rid of the 2 from the left hand side of the equation. So in order for us to accomplish this, we would have to divide both sides of the equation by 2. Thus, we will get the new equation to be 2y divided by 2 equals 28 divided by 2. Our next step is to cancel out the 2 on the left hand side of the equation. Thus that goes to 1, and therefore we will now have y by itself. So the new equation now becomes y equal 28 divided by 2. This we can easily solve, which the answer now becomes 14. So we have now solved for one of the unknown number, which is y equals 14. With this, we can now solve for the variable x. This we will use the new equation 2 that we have rewritten in terms of x. That is x equals 15 plus y. All we have to do right now is to plug the value of 14 into the variable y so that we can solve for x. This becomes x equal 15 plus 14. And as you can see, by adding these together, the result is 29. So from this, we can see that the two unknown numbers are x equal 29 and y equals 14. So based upon the question that we have, the sum of two numbers is 43. The difference of the number is 15. What are the two numbers? And we now see that the two numbers are 29 and 14. The idea here now is to prove that when you add both 29 and 14, the result should be 43. Also, when we subtract 14 from 29, the result should be 15. So let's prove that. The two original equations were x plus y equal 43 and x minus y equals 15. What we're going to do is to substitute for x and y in both equations to prove that 29 and 14 is indeed the correct answers to the equation. So as you can see right here, 29 plus 14 is indeed 43, and 29 minus 14 is indeed 15. I have also provided a shorter version of the problem, so you can check it out. Hope that this information has helped you. Thank you and goodbye.